Welcome to an overview of the transformer architecture, tokens, embeddings, and AI model training methods. The transformer architecture is a neural network using an attention mechanism to draw global dependencies between input and output. Unlike recurrent neural networks, transformers process entire sequences in parallel, capturing long-range dependencies more effectively. The core innovation is self-attention, allowing each word to attend to all other words, calculating attention scores to determine relevance. For example, in the delivery driver put the package in the truck because it was empty, it refers to truck. This mechanism helps the model make this connection, enabling deep contextual understanding. Multi-head attention breaks word vectors into chunks, applying self-attention to corresponding parts using Q, K, and V submatrices. Transformers typically consist of an encoder and a decoder. The encoder processes input, generating contextual embeddings. The decoder then uses these embeddings to generate the output sequence. Additionally, feed-forward networks refine language patterns and nuances learned during pre-training. Now, let's delve into tokens, context length, and embeddings, the fundamental units of AI processing. Tokens are the basic units of text and AI model processes, such as words, subwords, or characters. A model's capabilities, limits, and costs are all based on these tokens. 100 tokens are approximately 75 words. Context length is the maximum number of tokens an LLM can process in a single input sequence, acting as its short-term memory. A larger context window, like 128K tokens in GPT-4o and Llama 3.1, allows for more complex tasks, such as analyzing an entire book. However, computational cost scales quadratically with context length. A 4,096 token model requires 16 times more resources than a 1,024 token model. Embeddings are vectors or long lists of numbers that represent a token's meaning in a high-dimensional semantic space. In this space, related concepts like king and queen or Paris and France have similar mathematical relationships. Embeddings are how AI understands analogy, synonymity, and nuance. Finally, let's explore AI model training methods: pre-training, fine-tuning, and retrieval-augmented generation, or RAG. Pre-training is the initial, resource-heavy process of training a model on a massive dataset, like the entire internet. This results in a foundational model, such as GPT-4, with a broad understanding of language patterns. Fine-tuning is a secondary training process to teach a pre-trained model a specific skill or style using a smaller dataset. It adjusts parameters to suit particular tasks or domains, being more economical than pre-training. Retrieval-augmented generation, or RAG, gives a model access to external, real-time knowledge without retraining it. RAG works by retrieving relevant information from your knowledge base and adding it to the prompt as context. This is like giving the model an open book exam, significantly improving accuracy and reliability. RAG is the primary method we'll use for building knowledgeable AI systems, revolutionizing enterprise AI. Understanding these concepts is crucial for anyone interested in the technical workings of AI and large language models.